So I'm here at XYZ Machine Tools in Nuneaton. I'm with James Sanderson. Shortly we're going to do a demonstration on how easy this Robotend is, not only to operate but to program as well, to ensure that you can keep your machine tool running. James, if you'd just like to come this way, the first thing that strikes me about this unit is it's obviously portable, so you can move it from machine to machine, but it looks incredibly intuitive in the control. Is it?
Yeah, so we've designed it to be so simple to use for the operator, so that when they come to the machine and they want to set up a drawer, it'll take them 30 seconds to a minute to set up each drawer.
Okay, that's exactly what we're going to do now, so let's take a look.
Okay, so the operator will have already loaded the drawer with billets. They just need to tell the robot what size billets we're working with. So to do that, drawer setup page, say we're working from drawer 1. We input the billet data here. So in drawer 1 we have 100mm square billets. So I tell it that X is 100, Y is 100. They are 13mm high and weight of 1 kilo. Now we can choose the shape of the billet. We're working on square billets. Set billet data. It shows me the pin configuration that I need for that drawer, and it also tells me the maximum number of billets that we can use in that drawer.
So I'd move the pins into place and then I can load the billets?
Yeah, so it's fully configurable. You can move the pins about and you do that based on what size billets you are working with. So in this configuration we can have 45 billets. So I tell it we're going to have a maximum 45 billets. Set quantity, it tells me where to position the billets and how high to stack them. Once you've done that, set drawer. And then I need to tell the XYZ machine where I'm placing those billets. So in this XYZ machine here, we have 2 vices set up, and I want to machine both sides of that billet. So yes, machine both sides of the billet. The blank side that you pick from the drawer, place into vice 1. Then we take that machine part out of vice 1, put it on the turnover station, and place it in vice 2. So we say vice 2, flip side of the billet. And then you can have a number of different job types for the billets that you have in that drawer. So for this one, we'll just say we've got 1 job type. We're using all 45 billets. And we then need to tell the XYZ machine what job we're running with those billets. So you'll have all your jobs predetermined in the XYZ machine.
As in the programs for the operations?
Yeah, the programs. And you just need to tell it which one to run. So for this demo, we just say blank side, run job 1, flip side, run job 2, set vice data. And then if you just go back to here, drawer 1 is now set.
So you've set your drawer, now you just need to make sure that the vices can accommodate the billets, is that right?
Yeah.
Or the vices are in the right vices in the right place?
Yes, so when you're setting up a vice, which will be the first thing that you do, you place the vices on the bed of the machine. We say that your bottom left corner of the bed of the machine is your 00 reference point. And when you physically put the vices in the machine, we say roughly measure where you placed it, your center point of your X, your center point of your Y, and input that into the screen. And then once you've done that, the robot can then go in. We have little markers on the vice jaws, and we use the vision system to check that those vices are where you've said they are. And if they're slightly out, your X, your Y, or your angle is slightly off, we'll apply an offset to the robot so it knows exactly where to place them. And it'll do that every time that you set up a vice.
Okay, so then your vices are set. You've got your billets in your drawer. Yep. You know which drawer you're using. Yep. And so you're pretty much ready to go then?
Pretty much ready to go. Now, on this one, we have a servo gripper, which has a large stroke, so you can work with different size billets. But if you had a pneumatic gripper, the only other thing you would need to do is change your gripper fingers depending on what billet size you're running with. But if you have the servo gripper, you have an 80mm stroke, so you can work with quite a wide range of billets, and you don't need to change anything.
So once you've done everything you've done now, this is going to communicate with the machine, with the program. The two are talking.
Yeah. So we have a PLC, a Siemens PLC that runs Robotend. There's a Siemens PLC in the XYZ machine. And we do certain handshaking just to say where we both are, doors open, robot clear of the machine. And when you press go, the only thing that we need to tell the XYZ machine what job number to run. So once that's every time that places a billet into the vices, it says vice 1 is job number 1 or vice 2 is job number 2.
The only time the vision system comes into play then is at the start when it's working out exactly where the billets are.
Yeah, so when you first put a Robotend up against an XYZ machine, you have calibration checks with the vision system and a distance sensor on the end of the robot. And we do that so that if you haven't set the robot base perfectly level, it doesn't matter. It will use the distance sensor to get the plane of the bed of the machine. It will use the vision to look for markers inside the machine to alter the frame if it's out slightly. We've also got markers on the vices so it can pick up where the vices are. And every time it opens and closes the drawers, it does the same thing, uses the distance sensor to get the plane of the drawers and uses the camera to look for markers in the drawers. And it'll check it every time that it goes in, make sure those drawers are where.
Is there any way it can lose its path if you have a power out or something happens? I'm trying to find the pitfalls and the incidents.
Yep. So if you have a power out, all you would need to do is reset the robot job. So this will remember where you've said the vices are. It'll remember that you're up against this machine, but it will do a check if you have a power out, because it would essentially assume that you've moved the machine. But if you've got a power out, it will check the bed of the machine again, check that everything is okay and that you haven't moved it. But it will remember everything you told it. So if you haven't moved your vices, it'll still remember where you placed them. It'll just do the check again, take about 30 seconds.
If I want to move this then to my other machine, that's the whole principle here, isn't it? Being able to move it around the shop. How long is it going to take me to get it from here over to, let's say, my 1000 LR over there and doing the same operation? So I've got to set, let's assume the vices are set. How long is all that going to take?
We say it takes up to about 30 minutes. In reality, it probably isn't that long. So the robot is on wheels. All you need to do, it has feet that it sits on when you place it up against the machine. You just need to jack those feet up. You can then wheel the robot around to whichever machine you want to place it up against. And you place little data markers inside the bed of the machine for it to check. The process of it actually doing its checks takes about 3 minutes. The majority of the time is actually spent physically moving the robot or moving vices that you may need to swap over.
Or going in there and putting your billets in the drawers.
Yeah, or putting your billets in the drawers. The actual process of doing it all, its checks and physically, setting it up on the screen takes minutes.
The robot opens the drawers.
Yep, the robot opens and closes the drawers. So on this one, we've got 4 drawers. You can start off with drawer 1. Well, you can set all 4 drawers running. It'll run through drawer 1 once it's finished, close the drawer, go to the next one. It'll cycle through them all until it's finished.
Wow, that's all about spindle utilisation. This machine will just keep running. If you use this robot, you can move it around the machine shop on your XYZ machines. And you would probably look at a machine tool and think that you might get 30-40% utilisation out of the spindle because you're having to go in, load, change parts, turn parts over. With this, you could double your productivity on a machine immediately. That's brilliant. Thank you very much, James. Really great insight into the Robotend new from XYZ Machine Tools.